Assalamu alaikum. Today we have a question on a particle moving on a specific path. Sometimes it's convenient to use polar or cylindrical coordinates when we have the particle constrained to move on a path, maybe like a curve like this, or maybe a different curve. But the idea is that the particle is constrained to move on that. Now, that's not the only way to answer these questions, but if we have the question given in the r and theta, then we can use the so-called radial and transverse components of velocity and acceleration. Right, so here what do we have? We have a particle travel around a limaçon defined by the equation r equal b minus a cos theta. B and a are constants. Determine the particle's radial and transverse components of velocity and acceleration as function of theta and its time derivative. Now, the reason why I put this question mark here is that, in fact, the shape of this curve, which is known as the limaçon here, this shape depends, in fact, on the value of b and a, right? Now, I draw this curve here like this with an inner loop, assuming that the ratio of a over b would be less than 1. Right, so if we have that, or maybe b over a less than 1, then we will have this curve with the inner loop. Now, if the ratio between these two numbers is more than 1 or greater than 1, then the curve here would be different. But that will not affect our solution here. But just keep that in mind. In fact, we can have something like this, like a heart. Okay, so we have also this kind of curve, and we have something very similar to a circle. It's not exactly a circle, but almost a circle. Okay. Okay, so I just wanted to bring that up, even though it will not affect our solution. Okay. Right, to start with now, let me write the velocity, including the radial and transverse component. So the velocity as a vector has these two components. It's equal to the r dot u hat r. We just make this u hat r plus r theta dot u hat theta. Okay, and now this here r dot is the radial velocity, so this is just vr. Okay, and this one here r theta dot is the v theta, the transverse velocity. I know these are the unit vectors, u hat r, right? U hat r here, and u hat theta. Okay, now that's for the velocity. For the acceleration, it's a little bit longer. A equals, now we have r double dot minus r theta dot square u hat r plus 2r dot theta dot plus r theta double dot u hat theta. And this one here is simply AR, so that's the radial acceleration. And this one here is A theta, the transverse acceleration. So now what the question says, we want to find this VR, V theta, AR, and A theta. Okay, now to start with, we have, let me start with VR. Now VR simply is R dot, right? So I'm going now to take the time derivative of this. R equal B minus A cos theta. Now B and A, remember, they are both of these are constants, right? And now remember something important here. When we take the time derivative, remember we need to use the chain rule, because now we will take the derivative for the theta with respect to time, right? So now when we do this, equals, I'll have minus A, so B is 0, derivative for B is 0, minus A, right? Then now derivative for cosine theta, remember we take the time derivative, so here we have theta dot, right, times the derivative for cosine is minus sine, theta. Okay, so the answer would be simply A theta dot sine theta. Okay, so that's the answer for the VR. Okay, so that's theta dot here. Now for v theta, the transverse component of velocity simply is r theta dot, right, equals. Now think about that. Here, I don't need to take any derivative. Why? Because now r here simply is b minus a cos theta, right? And this is simply, sorry, here maybe I put dot by mistake. This is times theta dot. So that's the answer. Then remember, the question says we want to find the answer of these in terms of theta and its time derivative. So here we have theta and time derivative, theta and theta dot. So we are fine here. Okay, so we can just stop here for v theta. Okay, now about the acceleration, let me start by AR. And the radial acceleration simply is r double dot minus r theta dot squared. Okay, equals. Now to find r double dot, remember that we have found r dot here, right? So I can take the time derivative for this again. Here also I would like to think about this. Of course here a is constant, but here what do we have? We have here two functions. We have theta dot and sine theta. So we have to use the product rule of differentiation, right? So now let me do this here. A, I'll just take it outside, just a constant. Now let me start by the first one. The derivative for theta dot simply is theta double dot, right? And now we have the same, keep the second function the same, sine theta. Now plus the product rule. Now we need to fix the first one, so now it will be theta dot, right? Now times the derivative for sine theta, but what the time derivative? So what will be that? Will be theta dot, right? Derivative for sine is cosine theta. Okay, and what is that? Now this is simply just r dot, right? Minus r theta double dot. I mean theta dot squared. So now what is r here? So r simply I'll write the function itself given in the question. So it is just b minus a cos theta, and now this is times theta dot squared. So now if you think about this, the second term here, I just plug in the symbols, right? I didn't do any differentiation here, right? And now we can collect the terms together. So now we can leave it like that, or we can simply just collect the terms, right? And here, I mean this one here, theta times theta dot, will be theta dot square. Okay, so now if you collect the terms together, you will maybe arrive to something like that: theta dot square 2a cos theta minus b, right, plus a theta double dot sine theta. Okay, and that would be the answer for AR. Okay, now for A theta, the transverse acceleration, we have this, right? It's 2r theta dot plus r theta double dot. And now, you know what? Maybe here we don't need to do any differentiation. Why? Because we have all the results. R dot is here, so I will multiply that by theta dot, and now we have r. I multiply that by theta double dot, and that's it. Okay, so now I will have 2 times r dot, 2 times a theta dot sine theta. Now this is times also theta dot. Okay, plus now the r is simply b minus a cos theta times theta double dot. And you know what? I will just leave it like that. Okay, it's okay. So that's the answer. Okay, that's the answer for this question. I hope you found this video useful and you have learned something. Please don't forget to like and share the videos, and let us know in the comments if you have questions or suggestions, or if you want me to solve certain question or explain certain concept, please also feel free to let me know. Wishing you all good luck.